Good morning, students. I am Yadav. Today we will study about Polynomials, Chapter 2, Mathematics of Class 10. Today our topic is graph of a linear polynomial. Graph of a linear polynomial is a straight line and a polynomial is linear when its degree is 1. Then the polynomial is known as linear polynomial. And here we will draw its graph and we will see that this is a straight line. The graph of linear polynomial is straight line. Take an example: 3x plus 2y equal to 6. This is a polynomial. Its degree is 1. So this is linear polynomial. Now draw its graph. Take x axis x and x dax, y axis y and y dax. We will take some points x and y here. When x equal to 0, then y equal to 2 3 is 6, 3, and when y equal to 0, then 3x equal to 6, x equal to 2. Now we can take some more points also, but we can draw using these points: x equal to 0 and y equal to 3. 1 2 3. This point, this is the 0 and 3, and second is x equal to 2, y equal to 0. 1 2 3. X equal to, this point is x equal to 2, then y equal to 0, and this is 0 3. And join these 2 points, we will take a straight line. We will get a straight line. So the graph of linear polynomial is a straight line, and the general form of linear polynomial is ax plus b. Now second topic is graph of quadratic polynomial. Graph of a quadratic polynomial. The graph of quadratic polynomial is parabola. It's the shape of parabola, and this is quadratic, so its degree equal to 2. Now let us take some example. First, suppose polynomial px equal to x square minus 4. Then draw its graph. When we will draw this graph, then we will factorize this: x square minus 4 equal to 0. This is x minus 2, and x plus 2 equal to 0, or x equal to 2 and minus 2. 2 and minus 2. So this is 1 2. This is 1 minus 2. We will take some more points. Suppose this is x, y, x equal to 0. When you put x equal to 0, then y equal to -4, and x equal to 1, -3, x equal to 2, this is 0, and we can take some more point here. We see that 2 points, these are the zeros. This is quadratic polynomial, its degree is 2, so there will be 2 zeros, and which the graph will cut the x-axis at 2 points. This is x dash, this is y dash, y dash. Now we plot these points: 0, -4, x equal to 0, and y equal to -4. Suppose here is -4, 0, -4. So when we draw the graph will be like this. And secondly, take another polynomial px equal to -x square plus 4. Then when will we find its zeros? So we will get x square -x square plus 4 equal to 0. So 2 plus x and 2 minus x equal to 0. It keeps x equal to 2 and -2. Here for polynomial this and polynomial this, both zeros are same, 2 minus x, 2 minus x, but their graph will be different due to the sign of x square. Now let's draw its graph. You will see that this is x-axis, x dash, this is y dash. 2 zeros are 2 and -2. Suppose this is 2, here 1 and 2, and -1, -2. This is -2, -2, and similarly we will take some points x and y. When we will put x equal to 0, here we will get y equal to 4, and x equal to 1, y equal to 3, and so on. Now plot these points. These 2 points are the zeros. Now x equal to 0, y equal to 4, x equal to 0, and y equal to 4. Suppose this is 1, 2, 3, 4, x equal to 0, y equal to 4. Now you will see that the graph of this polynomial is like this. So this is depend on the value of the coefficient of x square. When the general form of quadratic polynomial is ax square plus bx plus c. This is the general form of quadratic polynomial. When a is greater than 1, then the graph will be like this. Here a is greater than 0, then the graph will like this, and when this will be negative, that is when a is less than 0, then the graph will be like this. It shows that the graph cuts the x-axis at 2 points, so there are 2 zeros. This graph cuts the axis at 2 points, there are 2 zeros. So we can say that there are maximum 2 zeros. And now take some other examples. Y equal to x square minus 2x plus 1. This is a polynomial. Y equal to, this is fx. Y equal to fx equal to this. Now we will take some points and draw the graph. So now take some point xy, x equal to 0, y equal to 1, x equal to 1, y equal to 0, equal to minus 1, and this is 4, this is 2, we will get 1. Now when we will draw its graph, then we will see that x and x dash, y and y dash, the factor of this polynomial is x square minus 2x plus 1 equal to 0, x minus 1 whole square equal to 0, x equal to 1. There are two values of x, 1 and 1. The roots of this equation is 2, 1 and 1, both are same, but these are the roots. But zeros is only 1. So the graph of this polynomial cut x-axis at 1 points. Suppose this is 1. The graph of this polynomial cut the x-axis at 1 points. Now plot these points: 0, x equal to 0, y equal to 1, 0, 1, x equal to 1, y equal to 0, this is 1, 0, and minus 1, 4, x equal to minus 1, y equal to 1, 2, 3, 4, some point here, and 2, 1, this is 2, this is 1. So the graph will like this. So here only one solution, because the graph touch x-axis at 1 points. This is, its 0 is 1 and 1. There are two roots. The roots will be 2, but 0 is 1 because the graph touch the x-axis at 1 points. So here we can say that the maximum number of zeros is for quadratic polynomial up to 2, and one more case, there will be no zeros for any quadratic polynomial. So now let's see third case. Take an example, y equal to x square plus 1, or y, this is fx equal to x square plus 1. So when we will write x square plus 1 equal to 0, then x square equal to minus 1, or x equal to plus minus under root minus 1. This is imaginary. So when we plot the graph of this polynomial, we will see that this is x dash, y dash. Take some points x and y, x equal to 0, then y equal to 1, x equal to 1, y equal to 2, x equal to minus 1, then also 2. Now plot these points, x equal to 0, y equal to 1, this is 0 1, x equal to 1, y equal to 2, x equal to 1, y equal to 2, this is 1 2, x equal to minus 1, y equal to 2, x equal to minus 1, and y equal to 2. So we see that the graph is like this. This graph above the x-axis, the graph doesn't cut the x-axis, so there are no zeros here. It has no zeros, number of zeros here, there are no zeros. You can see that there are no zeros, but roots are plus under root minus 1 and minus under root minus. There are two roots, and the roots are imaginary, two imaginary roots, so that it doesn't cut the x-axis. Now next topic is graph of cubic polynomial. Take first case, the equation is y equal to x cube minus 4x. When we draw its graph, then equate it to 0, x cube minus 4x, take x common, x square minus 4 equal to 0, x minus 2, x plus 2 equal to 0, so that the value of x will be 0, 2 and minus 2. So when we draw its graph, this is x dash, this is y dash. There are, this is minus 2. There are 3 zeros, 0, 2 and minus 2. So the graph cut at this point 0, minus 2, minus 2 and plus 2. The graph will cut the x-axis as minus 2 and 0 and plus 2. Now take some points between these 2 points and between these 2 points. Suppose 0 to take 1. So now we will find some points for x and y. X equal to 1, put in 1, then y equal to -3, and when x equal to -1, then y equal to +3, and this is x1 y -3, x1 y 1 2 3 -3. This is -3, so this point is 1, so that this point is x equal to 1 y equal to x equal to 1 y equal to -3, and second x equal to -1, here -1, and y equal to 3. This is y equal to 1 2 3. This point is x equal to 1 -1 y equal to 3. So graph will be like this, here and then here and then here and then here. This is the graph of this polynomial. There are 3 zeros, so the graph will cut at 3 points. Now take second case, when y equal to x cube minus x square, and solve it. X cube minus x square equal to 0, take x square common, x minus 1 equal to 0, so x equal to 0 and 1. There are 2 zeros, but roots, there are 3 roots, 0 0 and +1, but zeros are 0 and 1. X square equal to 0, x equal to 0, and x minus 1 equal to 0, then x equal to 1. Now draw its graph. You will see that when there are 2 roots, 0 and 1, here 1. Take some points for x and y. X equal to 1, y equal to 0, x equal to 2, y equal to 4, x equal to -1, y equal to -2, and so many points you can take. So x equal to 1, y equal to 0, this is 1 0, x equal to 2, y equal to 4, x equal to 2, y equal to 4, this will be here, and x equal to -1, -2, x equal to -1, here x equal to -1, y equal to -2, 1 2, -2, this is x equal to -1, y equal to -2, and we will take some point here. Suppose 0 and 1, we will take 1/2, then its value when we will put here, it becomes 1/8 minus 1/4 equal to -1/8. So this is -1/8. So this point is x half, y -1/8. Something is here. This is half and -1/8. So the graph will be like this. This is in this direction, and here like this, and in this direction. This graph cut x-axis as 2 points here and here, so there are 2 roots. This is degree is 3, but there are 2 roots because this cut the x-axis as 2 points. So roots, maximum roots will be 3 for cubic polynomial, but minimum is 0, 1, 2 and 3. In its roots may be 0, 1, 2, 3 and so on. Take a third example for this. Suppose polynomial y equal to x cube, then let x cube equal to 0, then x equal to 0. There will be x equal to 0, x equal to 0, x equal to 3 zeros. There will be no 3 zeros, only 1 zeros. So you can say that root is 3. Root in this case, root equal to 3 and 0, 0 and 0, but 0 are only 1 0. Now when we plot this graph, so we will take x, y, 1 and 1, minus 1 and this is minus 1, 2 and 8, minus 2 and minus 8. When we plot for this x and x dash, this is y and y dash, here 1 and 1, so this is 1 and 1, this is minus 1, minus 1, so this point is minus 1 and minus 1. Similarly 2 and 8, 2 and 8, here will be some points, and minus 2 and minus 8, minus 2 and minus 8, here will be some points. So the graph will be like this, will be like this. This cuts only 1 points, so at the origin, so there is only 1 zeros.